Polynomials. We have completed this chapter 2 polynomials. In this lesson, we will discuss some sample questions, some model questions from this chapter. So this is the file. Okay, these are some similar questions we have discussed in the class to find the zeros and verify the relation between zeros and the coefficients of the polynomial. Okay, and the last question a little bit different. Okay, so the first question. Find the zeros of the quadratic polynomial, that is second degree polynomial, 6x square minus 3 minus 7x, and verify the relationship between the zeros and the coefficients of the polynomial. So 6x square minus 3 minus 7x is the given polynomial. So I simply take p of x is equal to the given polynomial. So I shall write in the general form x square term first. So 6x square, then x term, that is minus 7x, then minus 3, the constant term. So we want to find out the zeros of the given polynomial. So the method we discussed in the chapter is you split the middle term, split the x term in such a way that their product should be equal to the constant term into the x square term. Okay, you minus 7x you want to split. Think two numbers. Their sum is minus 7 and their product is minus 3 into 6. Minus 3 into 6 means minus 18. Two numbers, their product is minus 18 and their sum is minus 7. So which two are the numbers?
Minus 9 and 2.
Minus 9 and 2. Minus 9 and 2. So you can split the middle term like this. 6x square same. Minus 7x you can split as minus 9x and plus 2x. So minus 9x plus 2x, if you add you will get to minus 7x. And if you multiply minus 9x into 2x, you will get to the product of the constant term and the x square term. That is minus 3 into 6x square means minus 18x square. Okay, so if you multiply these two also you will get the same. 2x into minus 9x also will get to minus 18x square. Minus 3, okay, minus 3 same. Okay, so next step you want to take something outside, common outside the bracket. So from the first two terms, so what we can take outside the bracket?
3.
3 only?
3x.
3x we can take outside the bracket. So inside the bracket what will be remain?
2x.
Okay, sorry, 2x
minus 3.
2x minus 3. Then the remaining term plus 2x minus 3 same. Okay. So now two terms are here, 3x into 2x minus 3 and 2x minus 3. So what we can take outside the bracket?
2x minus 3.
2x minus 3. Then what will be inside the bracket?
3x 1.
3x plus 1 will be inside the bracket and into 2x minus 3 will be
minus 3.
Okay. So zeros means the values of x when p of x is equal to 0. So here if p of x is equal to 0 implies one of the term 3x plus 1 or 2x minus 3 is equal to 0. So in this case there are two chances. One is 3x plus 1 is equal to 0 or 2x minus 3 is equal to 0 for p of x to be 0. Okay. So for these, from these two equations you want to find the value of x. Those values will be the zeros of the given polynomial. So how we can find the x from the first equation? X is equal to
1 by 3.
1 by 3, 1 by 3 or minus
1 by 3.
minus 1 by 3, right?
Minus 1.
Minus 1 by 3.
Minus 1 by 3. And from the second?
3 by 3.
3 by 2.
3 by 2. X is equal to 3 by 2 will be the second zero. Okay. Now you want to verify the relations. How you can verify the relation? What are the relations here? Relationship between the zeros and the coefficients of the polynomial.
Alpha plus beta.
Alpha plus
Alpha plus beta is equal to
b by a.
and alpha beta is equal to c
D
by
by a.
By a.
So here alpha plus beta means these two are the zeros. X is equal to minus 1 by 3 and x is equal to 3 by 2 are the zeros. Okay. So if you add minus 1 by 3 and minus 1 by 3 and 3 by 2, what will you get? Minus 1 by 3 plus 3 by 2, what will you get? This is alpha plus beta, okay? Alpha plus beta, what will you get?
7 by 6.
Okay, so
7 by 6.
7 by 6, right? In better 3 by 2 minus 1 by 3, right? So 3 into 3, 9 minus 2, okay, 7 by 6, okay? 7 by 6. And alpha into beta. If you do
Minus
find out
1 by
alpha into beta, what will come?
minus 1 by 2.
C by A.
Minus 1 by 3 into 3 by 2 will come.
3 by 2.
So you can cancel 3's. So the balance is minus 1 by 2.
By 2.
So compare with the minus b by a. Is these two same? Minus b by a. Minus b by a. Is that also 7 by 6? B is 7, right? So minus b by a
Yes,
is 7 by 6. So first is verified. Alpha plus beta is equal to minus b by a. Both are 7 by 6. And the second one, alpha into beta, minus 1 by 2. Is c by a also minus 1 by 2? Check it. C by a. What will be c by a here?
3 by 6 minus
Minus
3
3 by 6. If you reduce this, what will you get? If you reduce this,
Minus 1 by
1
2.
by
minus 1 by 2. So c by a is equal to alpha into beta. So both relations are verified. So for this you will get 3 marks. So you want to think about how much time you can spend for this question in exam room. Okay. The third question is almost similar. You simply say how we can split the middle term in the third question. The question number 15. How you can split the middle term in the third question in the set.
Minus 6 and 4.
Minus 6 and 2.
Minus 6 and 2.
2.
Okay, I will check it. So the sum must be minus 4 and the product should be minus 12. So how can you can split p of x? P of x is equal to 4x square minus 4x.
Minus 6 and 2.
Minus 6 and 2. Take the sum, you will get minus 4, okay? And if you take the product, also okay, that's also fine. So that's the choice. So you can write a 4x square minus 6x plus 2x minus 3. Then I don't continue the next steps. You can take some 2x outside the bracket, something, and you can continue. You can verify the relations. Okay. And the 16th question also, you can do the same. So simply say how you
Sir,
can.
14th question.
Okay, we'll come to that. These three are similar questions. That's why I jumped to 16th. Then we will go to 14th. Okay. So 16th question, same model question. So how you can split the middle term 5x?
8x minus 3x.
8x minus 3x. So you can check it. Okay. So given p of x is equal to question number 16. P of x is equal to 4 root 3x square. Okay. So plus 5x minus 2 root 3. So how can you split the middle term? Can you repeat please? 4 root 3x square.
8x minus 3x.
8x minus 3x. Right. Okay. Minus 3x minus 2 root 3. Very good. The sum of these two, 8x plus minus 3x will be 5x. And their product 8x into minus 3x will be the constant term minus 2 root 3 into 4 root 3x square, right? So you check the product 8x into minus 3x means minus 24x square. And these product minus 2 root 3 into the x square term, that is 4 root 3x square. If you multiply these two, you will also get a minus 24x square, right? So 2 into 4 is 8 and minus sign is here. Root 3 into root 3 will become 3. Okay, so minus 8 into 3 into x square will come. And in the next step, you can write a minus 24x square. That's what this product, 8x into minus 3x. So this is the choice. You can split 5x as 8x minus 3x. Then you continue, you will get another solution. Okay. Now come to the 14th question. How you can do this? Zeros are 1 and minus 3. Verify the relation between the coefficients and the zeros of the polynomial. So how we can do this? So what are given? Zeros are given, right? So I can take the given numbers. Alpha is equal to
1
1 and beta is equal to
-3.
-3. Okay. Verify the relationship between the coefficients of and the zeros of polynomial. Okay. So if alpha is equal to 1 and beta is equal to -3 are the zeros. So you simply write the quadratic equation first. Then verify to verify the relations you want to get A, B and C. That means you want to identify, you want to make the quadratic equation, you want to form the quadratic equation. So how you can form the quadratic equation?
Sir, by alpha plus beta,
Alpha plus beta,
then we will
We
get a
can
number
take 1 plus
that
-3
is
and 1 into
minus
-3.
coefficient by
okay, then what we can get, what we'll get then?
-3 plus 1 is equal to -2,
-3.
right?
Okay, but here we want to verify. We want to verify the relations. Therefore, we can't use that method because in that method, we will take alpha plus beta and alpha minus beta as you told, 1 plus -3 into 1 into -3, and we apply the relations first to form the polynomial. That is not possible in this particular question because here the second step is to verify the relations. So in the beginning we cannot use something that is not verified yet. Okay, otherwise you want to verify the relation first, then you want to use that. But the questions in textbook, that was fine. In those questions we applied that method to simply to form the polynomial. In those questions it was not asked to verify the relations, but here that is not the case. So we should go for some other method to form the polynomials. Let's discuss here. So if alpha is equal to 1 is a if alpha is equal to 1 is a 0, then we know that x alpha x minus, then x minus 1 will be a factor of p of x. Then x minus 1 will be a factor of p of x. And if beta is equal to -3 is a 0, then x plus 3 will be a factor of p of x. Okay, then this is a quadratic equation, so therefore their product will be the given p of x. So p of x you can write as x minus 1 into x plus 3. Okay, so now you can expand these brackets. So how will be the product? X minus 1 into x plus 3. X into x you want to do, x
X
into
square.
3. How will come? X into x,
X
square,
square minus
X
then
square
3x,
Plus
minus
3x
plus
3x
3x
minus
minus 1x
then
minus 3
minus 3. Now arrange in the standard form. X square first,
square
then
plus
X term
plus 2x
plus 2x, then
-3.
-3.
minus 3. Now what is A, what is B, what is C? A is 1, B is 2, C is
-3.
-3. Okay. Now you check whether alpha plus beta is equal to minus B by A and alpha beta is equal to C by A. You can check and it will be definitely holding. Okay. So this is the idea. If you get similar question, you can do like this. First, to form the quadratic equation. How? If alpha is equal to 1 is a 0 of the given polynomial, then x minus 1 will be a factor of p of x. And if beta is equal to -3 is a 0 of the polynomial, then x minus -3, x minus -3 means x plus 3 will be a factor of p of x. Okay, that's some theorem you have studied in the 9th standard. If x minus a is a factor, then p of a is equal to 0. That means a is a 0. A is a 0. This is some theorem you have studied in the 9th standard. Okay. So the last question, if the zeros of the polynomial be in the ratio 2:3, prove that 6p square is equal to 25q. That's the question. We want to prove it. Okay. So if two zeros are alpha and beta, given that alpha into beta is equal to 2:3, Then by some theorems we have studied in lower classes, you can assume that there exists a quantity x such that alpha is equal to 2x and beta is equal to 3x. There will be existing some quantity x such that alpha is equal to 2x and beta is equal to 3x. So next you apply the relations. Alpha plus beta. What is alpha plus beta? Alpha plus beta minus b by a. You apply the result. So alpha plus beta means 2x plus 3x. That is 5x. 5x is equal to minus b by a. What is minus b by a here?
P by 1.
P by 1. That is 5x is equal to p. Okay. Apply the second result. Alpha into beta is equal to, find the beta is equal to
C by A.
C by A. So that is alpha is 2x, beta is equal to 3x. So 2x into 3x is equal to C by A. C, what is C here? Q.
Q by 1.
Q by 1. So 2x into 3x, what?
6x square.
6x square is equal to Q. 6x square is equal to Q. Okay. So we are almost near, almost close to this result. So 6p square we need. So 5x is p. So you multiply both sides by, you take the square of both sides here. So 5x all square is equal to p square. So I do the next step here. Okay. So 5x all square means 25x square is equal to p square. And now you multiply both sides by 6. So you will get to 6 into 25 x square means 150x square. That is equal to 6p square. That is the LHS. 6p square is the LHS. We got that 6p square LHS is equal to, we got LHS is equal to 150x square. Okay. And from this equation we can form the RHS. 6x square is equal to q. We need 25q. So what will be 25q? What will be 25q here? 25q means 25 into 6x square will come. So what is 25 into 6x square? 150x square, right? Okay. And this is the RHS. Okay, RHS is 150x square. LHS is also 150x square. That is 6p square is equal to 25q. I hope you got the idea. Finally, you will get the LHS equal to RHS. That is 6p square is equal to 25q. That's the answer to this question. Okay.